Hey guys, today we're going to be multiplying decimals. Now before we get started with just using numbers, I want to kind of show you to help you better understand where we find our solution. So the first example I'm going to give you is 2 times 2 5/10. Now remember, multiplication is repeated addition. So I could easily off to the side add 2 5/10 to 2 5/10. But I want to use base 10 models to help you understand what's actually happening. The first thing we're going to do is we're going to draw, using base 10 models, 2 5/10. So I've got 1, 2, 1, 2, 3, 4, 5/10. Okay? Now, because this represents the original total of 2 5/10, and we are multiplying it by 2, we're actually going to go ahead and draw another set of 2 5/10. And right now we are showing the total using base 10 models. So I'm going to go ahead and count up our total to figure out what our answer is going to be. So I have 1, 2, 3, 4 ones so far. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, remember when you have 10 tenths, this is equal to 1. 10 tenths is equal to 1. So right now I have a total of 5 ones, or 50 tenths rods. Because remember, there's 10 in each ones flat. So this is the easiest kind of adding or multiplying. So let's step it up a notch. Let's get another challenge. Okay, this time we are actually going to be multiplying 1 2/10 by 2 5/10. What they want to know is, what is 2 5/10 of 1 2/10? What is 2 5/10 of 1 2/10? We've kind of worked on using that, recognizing that word of with fractions, because multiplication is asking you what is a total of a total. It gets a little confusing, but hang in there with me. So the first thing we're going to do is we're going to actually model one of these decimals going horizontally. So I'm going to start with the 2 5/10, and I'm going to actually model it using one color to make it easier to recognize. So I'm going to draw, that's 1, 2, 1/10, 2/10, 3/10, 4/10, 5/10. Okay, so we have our 2 5/10. Good to go. Now I need to work on my other decimal, my 1 2/10. This is important to remember. When you're multiplying, just like fractions, we need to go in the opposite direction. So now we're going to go vertically. Now I already have 1 modeled so far. So now I just need the 2/10. Okay? This is the part that gets a little confusing, so stay with me. There's a missing section right now. This blank area needs to be filled in. So the way we fill it in or complete it is by using the base 10 models. And this is going to help us figure out what our solution is going to be, what our product is. So right now, underneath the ones flat, there is a tenths rod that is equal to that selection, okay? Now from here, I can't necessarily fit in a tenths rod to go underneath each base 10 model. So I'm going to use the next unit, which is the hundredths unit. Okay? And now that we've filled in that missing area with the base 10 models, this is going to actually help us figure out the solution. So let's use our models to help us find what the actual solution is. So far I've got 1, 2 ones flat. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, tenths rod. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. Well, we all know I can't place a 10 here. It wouldn't necessarily work out because that's only equal to 1. So I want to go ahead and exchange those 10 for a 100th. Okay? So that means that my answer is going to become 3. Okay? So here's what that looks like with regular multiplication. And this is where you might want to pause and kind of soak in what we just did. I'm going to use a different color. I'm going to use white off to the side to show you, okay, if we were to actually multiply this just using numbers, how does that equal this? So I've got, 1 and 2 tenths times 2 and 5 tenths. Now I know in this case the decimals line up, but with multiplication, you do not have to worry about lining up place values. That is because every single place value is being multiplied by another place value. So we don't have to line up our decimal points. In this case, it just happens to work out perfectly. 5 times 2 is 10. Carry over. 5 times 1 plus 1 is 6. It's really important to remember multiplication. We're moving on to the next place value. So we're going to have our 0 put there as a placeholder, and now we're multiplying the tens place. 2 times 2 is 4, and 2 times 1 is 2. So I'm going to add up my partial products, and looky. Now this says 300. Now this is not 300 ones. It's really important to understand, and I'll kind of go over this a little bit later, is that we need to recognize how many place values are behind the decimal. So when I take a look at my above problem, I notice there is 1, 2 place values that are behind the decimal. So that means that in my answer, I need to make sure there's 1, 2 place values behind the decimal. And sure enough, our model accurately gives us the product. Okay, this is working with a decimal that is less than 1 and multiplying it by a decimal that is less than 1. So we have a hundreds flat, which in the past is represented 100. But remember, we're working with a hundreds flat that is equivalent to 1, okay? So just remember that this is actually equivalent to 1. So within this ones flat, we only need 1 because our decimals are less than 1. We're going to start off using the 6 tenths. And we're going to actually shade in, going horizontally, 6 tenths. And I'm going to shade in each individual square so that it's actually easier to tell what overlaps. So that's 1/10. Okay, so now that we have 6 tenths shaded in, we're going to use a different color, and we want to go the opposite direction because we are taking 3 tenths of 6 tenths. So going this way, very similar to fractions, we're going to shade in 3 tenths. All right, so that's 1/10. Okay, so now that I have each decimal represented on the ones flat, we want to make sure we recognize where our solution is. So our solution is actually where the 2 colors overlap. This is really important to understand. So the 2 colors are overlapping here, okay? This is where your product is shown. So we're going to go ahead and count to see what our product will actually be. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, we have 18, but remember, this is 18 out of 100. So we want to make sure that our answer is represented as 1800ths. All right, guys, I know that you've gone through a lot so far. So if you need to pause, take a break, get some snacks, this is our last session as far as going over multiplying decimals. Sometimes you're going to read a word problem or simply see a standard algorithm as I've shown you. 3 2600ths times 1 3/10. Well, it's very similar to multiplying whole numbers. So it would almost be as if we were multiplying 326 times 13. The only difference is that we're going to have to be very cautious about where we place our decimal point, because you have sections of this number that is less than 1, and then sections of the decimal that are greater than 1, okay? So let's go ahead and get started. 6 times 3 is 18. Carry the 1. 3 times 2 plus 1 is 7. 3 times 3 is 9. So I've taken care of the ones place, and now we are on to the tens place. Remember, now that we're on to the tens place, we want to make sure we have a placeholder. 1 times 6 is 6. 1 times 2 is 2. Don't be fooled by that 1. We've already worked with it. And 3 times 1 is 3. Let's go ahead and add up our partial products. Now, I can't stop here because remember, this would be as if I were multiplying whole numbers, but I'm not. There are sections in the decimal that are less than 1. So, something I've talked about earlier is that you have to pay attention to how many place values are behind the decimal points. So, in my standard algorithm, I have 3 place values that are behind the decimal point. That needs 3 place values will be behind the decimal point in my product. 1, 2, 3. You can either use this underhanded jump or underline them, but my final answer is 4 and 238 thousandths. Not to be confused with 4,238. It's a big difference in our amounts, so be careful on that. Thanks, guys. I know this is a longer video, but I appreciate you guys hanging in there. Take a couple minutes to go back and rewatch whenever you need it, or ask a parent or someone in your family to create some decimal problems for you and use the video as a guide to help you practice. You're going to be great.